Hi everyone, and welcome to a new part, like a new series on this channel. This time we will have, I think I'll call it something like a to be physicist or a to be astronomer reacts to the flat Earth replacement for gravity, which is the incoherent electrostatic acceleration. And I found a video in the link list of Shane St. Pierre, which is another flat earther, which is not listed. So I'm unsure if I want to share the link with you because clearly it's unlisted. So it's from a person called Good Times for All, and he tries to get rid of gravity and substitute it with the incoherent electrostatic acceleration. He has made 2 videos, as far as I know. And yeah, let's have a look see, shall we?
Hello, everybody out there in YouTube land. This is Good Times for All, or Zachary Zabala if you prefer. In this video, we will be explaining how incoherent electrostatic acceleration creates the downward vector.
In the downward vector that is needed for a downwards acceleration, because acceleration has a direction, right?
Gravitation, a word which many do not comprehend, is a theory that was created to explain the paths of the luminaries above.
Yeah. Well, yeah. I mean, it wasn't created for that, right? It was created, if you will, more observed than anything else. Of course, way earlier than that, I would refer to Galileo's experiments of a sloped surface, his drop experiments, when he had no idea yet about the orbits of planetary bodies. That came way later. That really only took hold with Johannes Kepler, but so it wasn't really created for that. It was created to explain why there is a downward vector. So yeah.
And what keeps them in orbit around other bodies, including.
Although it was later, of course, used to explain the orbits of planets around other bodies and things like that,
including our Earth. It has been known and taught in college-level physics courses that the electric forces that hold the Earth together are 26 times stronger than the gravitational forces that are supposed.
It's not. I mean that's wrong. Certainly not 26 times. More like 10 to the 26, right? This comes from something that you do very frequently in your entry classes to electrodynamics. At least we did it in both of my entry classes to thermodynamics, electrodynamics, because the university where I attend, you have an experimental course for everything. So I had experimental electrodynamics, and then you have theoretical electrodynamics, and we got this comparison for both. It's when you compare the gravitational pull between a proton and an electron at typical atomic sizes to their gravitational pull, and then you conclude that the pull that results from electrostatics in this case is about 10 to the 26 stronger. So not 26 times, but 10 to the 26 times. And I know where he's going with this one, right? That's a very common thing that flat earthers do, is they say, well, if it's 10 to the 26 times stronger, then how can we think that there's gravity, and how can we pretend to measure gravity if everything has electrons and protons and things like that? Which is funny, because there's a very well-known way with which to remove, for practical purposes, all electrons from a body, thus making it not electrostatic anymore for practical purposes, which is grounding. That exists. But I may do a quick calculation later to show how much charge you would need to falsify, to really influence things like the Cavendish experiment and things. Yeah, let's continue.
Supposedly here on Earth. I will now show you a short video of former MIT physics professor Walter Lewin explain this quite clearly.
So what holds our world together? Well, on the nuclear scale, 10 to the minus 12 centimeters, very important are the nuclear forces. On an atomic scale, up to thousands of kilometers, it's really electric forces.
Mostly, I wouldn't go thousands of kilometers. I would go hundreds of kilometers. But I agree for the most part. For the smallest things, you need the strong and the weak nuclear force, right? Clearly, that's why they're called nuclear force, because we detected them when we fought and when we experimented about the nucleus. The electric force, or electrostatic force, or electromagnetic force, whatever you want to call it, really is the force in our day-to-day lives, except for when you talk about things falling down, right? I hold up my microphone. By the way, I got a new microphone. I hope you can hear it. I invested a whole €30, €30 into a used microphone, because it's not because the only microphone I had earlier was the one that came on my headset, and while it was fine, this is better, and for €30, I don't care. So yeah, electric forces. That the reason why I can hold up this this microphone is due to the electromagnetic force repelling between my hand and the microphone, or the table and the microphone, if I have set it down right. So in our day-to-day lives, that's an important force. Like, even without talking about all of our electronic applications that we have nowadays, right? Because the microphone is an electric thing, and it uses the electromagnetic and electrostatic force to process information. So, but I don't think he's talking about that. But that's, of course, another use case of the electromagnetic force.
That hold our world together. But on a much larger scale, planets and stars and the galaxy, it is...
He says lights in the sky, which I think is funny. Flat Earthers and a couple of other people always like to say, well, the lights in the sky. Well, what do you mean the lights in the sky? You can literally buy a cheap telescope. I got my telescope. I got my telescope for €25. €25. Used, because I buy almost all of my stuff used. And with that, you can on a good day literally see the rings of Saturn. Not well, but you can see that it is not as how do I put it? It's when I look at Jupiter, for example, you can definitely see that it's not a point anymore. You can see that it's a circle, right? And when you look at Saturn, you can see that it's not a circle, but you can, if you think about it, you can make out that there is kind of something else that is disc-shaped around the thing, right? So, lights in the sky is essentially saying, nah, I don't believe the astronomers.
It's gravity that holds,
which is just dismissive at this point,
our world together. And now you may say, that's very inconsistent with what you just told us, because didn't you tell us that D cancels if you compare gravity with electricity?
Yes, but keep in mind that most objects in the universe have only a very small amount of charge per unit mass.
Exactly. I love how he said in the heliocentric model, because he selectively agrees with things that Walter Lewin says, and then selectively disagrees with the other things, which, that's how you know that someone is genuine. If they say, well, that part of the source is crap and the other part is completely bang on, so that's always nice. But yeah, for practical purposes, you can assume planetary bodies to have no charge whatsoever. They have charge. I read about it. I believe Mars has a charge that is so small that, like, the gravity, the order of magnitude, is like 10 to the 16 stronger than electromagnetic force. I think it was 10 to the 16, something like that.
The Earth and Mars have each a charge of about 400,000 coulombs.
Well, there you go.
The gravitational force between them is therefore about 17 orders of magnitude
17
larger
I
than the
thought
electric
of
force.
16, and apparently they have 400,000.
So even though our
coulombs,
immediate
which is
surroundings
very
are dominated by electric
force. Yes, our immediate surroundings are dominated by electricity, although keep in mind, you're still being held to the ground by gravity.
Including your own body, for that matter.
And I mean, it's not like you couldn't calculate the force of gravity, right? I mean, you can calculate how much the force of gravity pulls you down, and you can measure that with a scale, for example, and you can see that it comes to pretty much what you calculated. So,
The behavior of the universe on a large scale is dictated.
Yes, again in the heliocentric model. So only, again, he agrees with what he said prior to that, but he disagrees with the thing that he says now, which is like literally a sentence later.
By gravity.
I find it so funny when flat earthers use scientific resources or like lectures to justify their thing. Or I don't even know if he's a flat earther, right? I think he is, but like, why would you use scientific sources to do that if they fundamentally disagree with the rest of what you're saying? It's so funny.
As you heard, the professor state gravity does not take place until we start talking about a moon orbiting a planet, the planet orbiting a sun.
He doesn't say it takes place. He says, "Oh God, I'm sorry, I knocked over class." He doesn't say it doesn't come into play. What he says is that it is the dominant force at these scales, because at smaller scales, like what we have now, electromagnetism, in our daily interactions is kind of the force to go. Although, like, the more I think about it, the less I agree with that, because like when I pour some liquid into a glass, which comes to me because I just knocked over a glass, the thing really is that, well, I can only pour it in because of, well, gravity, and the thing that keeps me in my chair right now is gravity, even though the chair pushes against me using the electromagnetic force. So I guess I understand where he's going with it, although I don't completely agree.
Or stars orbiting the center of their galaxies. I fully agree that this is a theoretical concept that is unproven.
Okay. Another flat earther who doesn't know what theory is in science and who thinks that science proves. Okay. I showed you last time in the conclusion of my geocentrism documentary reaction, I showed you the hallmarks of pseudoscience, the 11 characteristics. One of them is to talk about proof, right? Because science fundamentally doesn't and can't prove, because the way that science is built up, absolute proof would be a detriment to the progress of science. So of course there's no absolute proof for anything. And I think it's so funny that flat earthers continuously say, well, it's not proven. Yeah, well, oh, would you look at that? Big surprise. A theory, like a method of finding out stuff about the universe that like itself says we don't prove, and then they say, well, you didn't prove it. Yeah, well, big surprise. It's like some car company only selling yellow cars, and which would be fun. And then there comes a flat earth and says, well, all of your cars are yellow. And then they say, well, yeah, big surprise, right? Also, it's a theory. In science, a theory refers to something that, like, a theory is really the highest something can go, because sometimes people think it's like hypothesis, theory, and then law, but it's not. Something that's a law can never become a theory, because a law usually explains something small, right? And if you have a whole bunch of laws connected with some ideas of how they interact that make predictions that are true as far as we can tell, right, then that becomes a theory, and a hypothesis is just a fancy guess, really. So gravity is a theory because it has a lot of supporting laws behind it. Newtonian law of gravity, for example, the Einstein idea of gravity, and it is a theory because it has a quite big amount of scientific evidence behind it, both from just mere experimentation and observations, and also from predictions that came true. So I love when philosophers say that gravity is just a theory, or I sometimes also, you can hear it from evolution deniers, that evolution is just a theory. That just tells me that they don't know what a theory is and that they have very little to do with actual science. So this is going to be fun, and I'm only in 2 minutes, and oh god.
Still today, and find it odd that they need ideas such as dark matter to make up over 90% of their model to explain how it is possible.
Dark matter is not needed to explain gravity and our scales that are relevant to humans. Dark matter plays no role within the solar system whatsoever. It is not needed for the explanation of gravity. dark matter, and I attested to this earlier in the other series. The thing with dark matter is that there are a few places from which we would need some matter that cannot be seen because it most likely doesn't interact with the electromagnetic force. It does, however, interact with the gravitational force. There is for example, you kind of need it for rotation curves. You kind of need it to explain the mass of supermassive clusters, and things like that. Now, the thing is, dark matter, as of now, is our best hypothesis for that. And I say hypothesis here because we do not have any supporting evidence for it. But it's like a few fields also from the more fundamental physics side of things, like from quantum physics and from particle physics, point roughly in the direction of dark matter, right? So for now, this is the best shot that we have. But if something else comes up that's not dark matter, and we figure out something else, we'll be absolutely happy to ditch it. The picture that he's showing here is just our current best idea, right? And it's not like, oh, because we're absolutely sure that it's there, because we're like, no, we are reasonably sure that it should be there, but if it's not, we'll ditch it. No problem.
Such as dark matter, to make up over 90%.
And I'm at 16 minutes already. And I haven't even reached 3 minutes yet. What have I got myself into this time? Oh well. Regardless, that was the first episode. Thank you very much for watching. If you enjoyed it, and if you enjoyed the new microphone, which I hope you do. I hope I got all of the settings right and this is not horrible audio. Feel free to maybe leave a like. That would be highly appreciated. And do all of the other YouTube things that people are supposed to do. And until then, see you next time.